So let's work through an example of projectile motion. And this is going to be example number one of a cliff problem. And this is question number one. And it says an arrow is shot horizontally towards point O, which is a distance of 20 meters. It hits point P 0.1 seconds later. So a tenth of a second later, it's at point P. What is the distance OP? And then what is the arrow's initial velocity? So here's some things that we need to look at. So this is distance in the X, and that's going to be 20 meters. This is going to be my distance in the Y, and that's going to be really what I'm looking for, right? So that's SY. It says that the time that it's in the air is 0.10 seconds. So when we're looking at projectile motion, again, we need to break motion down into X and Y. My initial velocity in the X is unknown. My displacement in the X, that's going to be the 20 meters. In the Y direction, my initial velocity in the Y is going to be 0. It's not going up or down. It has some velocity here in the X direction, right? So it has some initial velocity in the X, but it's not shooting upwards or downwards. So there is no Y motion initially. My displacement in the Y is what I'm looking for. I know that my acceleration in the Y, that's going to be little gravity, or negative 9.81, or negative 10 is what I'll use. When we're just doing book problems, again, negative 10 is perfectly good to use. And when we're talking about projectile motion, the one thing I can take back and forth is time, right? So it doesn't matter which way, whether it's X or Y, that's going to be the same. So the first thing it asks for, what is the distance OP? And that's really SY. So what I can look at is is 0.01 seconds. So now let's find SY or OP. That's the distance between O and P. When I look at that, the three things that I have is I have time, I have acceleration, I have an initial velocity, so then I can find my displacement. To do that, I'm going to use the equation S equals initial times time plus 1/2 AT squared. I'm going to see that my initial velocity in the Y is 0, so that's going to go away. So then I'm just left with S equals 1/2 AT squared equals 1/2 times negative 10 times 0.1 squared. When I do that, 0.1 squared times negative 5 and so my distance in the Y is going to be 0.05 meters. So that's how far it went. That's about 5 centimeters, not very far. Obviously, it was not in the air for a very long time, a tenth of a second, and so it's not going to travel very far. So that's the first thing I would do to find SY. Second thing is ask, what is the arrow's initial velocity? So initial velocity is just UX, right? So that's how fast it's going in the X direction. So second thing is I'm going to find UX. To do that, the one equation really that I can use, I can use this equation again, and that's really where it comes from. The understanding is that S equals UT plus 1/2 AT squared. In this situation, because we're talking about the X, there is no acceleration. So really this equation becomes S equals UT. And I'm solving for then U. So it's going to be U equals S over T, or just this simple idea that, again, speed equals distance divided by time. In the X direction, there is no acceleration, so it's just a constant velocity, which we can use just velocity equals displacement over time, or speed equals distance over time. Same idea. We can plug this in as 20 divided by 0.1, and that's going to be an initial velocity of 200 meters per second.